Well, hey there, everybody. It's your boy, Mr. Perry, and here we are back at it. Unit 7, Lesson 6. This time we're learning about the selection and the insertion sort. So let's get started. All right, we're going to do a little bit of an opening question here. If you were given a list of numbers, and the numbers are all right here for you, as you can see, they are not in order. Describe a strategy to put these numbers in order from the smallest to the largest. Your strategy should work for any list of numbers, including a list that has some values repeated. So what you can do right now is you can just kind of pause and think about how you would do this in your head. If you're just kind of looking at the list, as a normal human being, how would you do it? Then think about how you would program Java to perform this task. What variables would you need in order to make it work? And, just in a general sense, try to get a sense of how it would work. As always, I'm going to encourage you to pause the video and think through this. But in the meantime, I'm going to go ahead and keep going, and we'll look at what this, how this actually takes place in Java and what some of our options are. So we are getting into what are called sorting algorithms, and there are several sorting algorithms that you need to know for your exam. We're going to start with the selection sort and the insertion sort. Now, there is a third one called the merge sort that we're going to be getting to later in the class. Now, the good news is you do not need to memorize the code for either of these sorts, but you should be able to recognize the code and know it by name. So if you see the code for a selection sort, you should know, oh, this is the selection sort. I know how this works. And the same thing for the insertion sort. If you see the program code for it, you should recognize it. You should be able to say, oh, this is the insertion sort, and you should have a general sense of how it works. These two sorts can be easily programmed using loops and iteration, as you'll see. Now, the other thing that you should be able to do is you should be able to conduct what are called runtime comparisons of these sorts. And what that means is you'd be comparing statement execution counts and seeing which one sorts more quickly. So in other words, you should be able to understand how the code works and understand which sort is actually going to sort the list more quickly than the others. All right, so we're going to go ahead and look at just the general pseudocode for a selection sort and look at how it works, and then we'll work through an example. So the selection sort basically does three things. It starts by assuming that index 0 is the smallest. And what it does is it checks the rest of the array. So starting at index 1, it's going to start looking for a smaller number. If 1 is found, then those values are swapped. Then you basically repeat step 1 and 2 for the rest of the array, starting with the next index value. So you would then assume that index 1 is the smallest, and you would loop through starting at index 2, looking for something smaller, and then swap them if you find them. Now note, you do not have to process the last element in the array because that's already going to be sorted by the time you compare all of the prior elements leading up to it. So by the time you get to the last element, the entire array is going to be sorted using what's called the selection sort. So let's use our pseudocode to walk us through an example here. So again, the selection sort works like this. We're going to assume that index 0 is the minimum. So right now, we're just going to assume that 3 is the smallest item in this list. Now we need to check the rest of the array for a smaller number, and if 1 is found, we're going to swap those values. So no values are less than 3 are found on the first iteration. So basically what happens is 3 swaps with itself. So no big deal, it just doesn't change position. Now we're going to repeat steps 1 and 2 for the rest of the array, starting with the next index. So now we're assuming 9 is the smallest value, and it is going to loop through the rest of the array, and it's going to find the next smallest, or it's going to find the smallest of the rest of them. Obviously, when it loops through, it's going to determine that 4 is the smallest number. So now 9 and 4, the first instance of 4, would swap. So that's now done. Now you're going to be looking at index 3, which is the number 9. That's where it ended up. And we are actually index 2, I should say, but the third element. And now we're going to check the rest of the array, looking for something smaller. And this time, the smallest of the rest of the array is the number 4. So now 9 and 4 are going to swap. And now index 0, 1, and 2 are sorted. So now we're going to look at index number 3, which is 8. So now we're assuming 8 is the smallest. We're going to check the rest of the array for an even smaller value. Of course, we find one right here at 5. Now those are going to swap. Now the index is going to go up to, let's see, we did 0, 1, 2, 3. So now the index is going to go up to 4. We're going to assume 9 is the smallest. But obviously, when we look at this one, we know that 8 is also smaller. So those two values would swap. And now we've got to the end of our array, and there's no need to check this final index because, again, we've already checked the rest of the array. Everything preceding it is a smaller value. So at this point, the selection sort would be done. What you see right here is the actual selection sort program code in Java. So let's go ahead and walk through it. We've got we're going to be sorting an integer array from low to high. So that's our parameter being passed in called elements. Now we have our for loop, and we're saying for int j equals 0 as long as j is less than elements.length minus 1. So when you see this right here, this is one of your clues that this is a selection sort, because your outer loop is not going to loop the entire array. We're going to stop when we get to the seconds to the last element. So the outer loop of a nested for loop starts at index 0 and ends at the second to last element. Now it says int min index equals j. So we are assuming that index 0 is the minimum value, and the unsorted part of the array starts at index j. Now it says for int k equals j plus 1, as long as k is less than elements.length, k plus plus. So what we have here is a nested for loop, which is starting at index 1 instead of index 0 on the first iteration. So this is what's going to check the rest of the array. Remember, you've got to pay attention to what is your first index, but now you need to loop through the rest of the array. So that's what this loop is doing right here. The inner loop traverses the unsorted portion, comparing each element to the first element in the unsorted portion, which is up here. So now that we're using k to loop through the rest of the array, what we're doing is we're checking if elements at k is less than elements at the min index, which again is 0, currently. Now, if we do find an additional element that is less than the elements at the minimum index, then we need to change our min index to be k. So if we find another element that's smaller, the index of the minimum value is no longer going to be j, it needs to be k. And then finally, what you see down here is int temp equals elements at j equals elements at min index, and then elements at min index is equal to temp. I don't know about you, but this looks a lot like the swap algorithm, and that's because that's what's happening. What ends up happening at the end of the selection sort is that you create a temporary variable and you store the element at j, which was our original value. And then we say elements at j is now going to be elements at the minimum index. So whatever value ended up being the smallest, whether it was the original value or whether it was something else in the array, it's now going to be stuck, in that position, elements at j. And then finally, you complete the swap. Elements at min index equals temp. So whatever was originally at that position j gets put back in for elements at min index. So this is what performs the swap. So essentially, for the selection sort, you've got a nested loop. You have a loop inside of another loop. The outer loop controls, what value you are currently looking at. The inner loop is what checks the rest of the unsorted array, looking for something even smaller than that current, index of the minimum. And then finally, you make the swap at the end. So that is the code for the selection sort. So we're going to look at just a couple of quick questions, and then we're going to do the same thing for the insertion sort. So a quick question here. Under what condition will a selection sort execute faster? Now that you know how it works, which one's going to execute faster? If the data is already sorted in ascending order, if the data is already sorted in descending order, or it will always take the same amount of time to execute. Go ahead and pause the video. Think about how you would answer that question. I assume you paused the video. We're going to go ahead and look at it. And the correct answer is C. And the reason why is that, the selection sort always checks the entire array. You start at index 0, you check the rest of the array for something smaller. If you find something smaller, you swap it. If not, it swaps with itself, and then you go to the next index. You're like, okay, now this one's the minimum, and it checks the rest of the array. So it really doesn't matter whether or not the data is already sorted at all, because the selection sort always checks the entire array. And then finally, another quick question here. What you see here is some buggy code. This method should sort the numbers in the array that's getting passed in ascending order, but it does not work. So there are 5 lines that are labeled here. Can you find which line is incorrect? Again, I encourage you to pause the video, read over the code, see if you can find it. I assume you paused the video. Let's go ahead and move on. And so the one that is having the problem here is actually right here. It's our inner loop. The outer loop is going to start at 0, and it's going to loop through the length minus 1. But the inner loop is the one that should be checking the rest of the array. And so that means this one, int k, it should equal to j plus 1. That way, when j is 0, k starts at 1. When j is 1, k starts at 2. When j is 2, k starts at 3, and so on and so forth. You always want to make sure you're checking the rest of the array. So there you go. All right, we got one more of these to look at. Now we're going to look at what's called the insertion sort. So the insertion sort pseudocode works like this. Instead of starting at index 0, we're going to start at index 1, and we're going to remove it. And we're going to see if that value is actually smaller than the one before it, index 0. Then we're going to check the next index and see if it's smaller than the previous values. Now, if it is smaller, what's going to happen is you're going to slide the larger values down and then insert the element you're currently checking where it's supposed to go. Finally, you're going to check the next index and see if it's smaller than the previous values. And once again, you're going to insert it if it's smaller. So this one's a little bit different because it kind of works backwards. It starts at index 1 and then it works backwards. And well, let's go ahead and check it out and see how it works. So here's that same array. And so let's go ahead and follow our pseudocode. So the first thing we're supposed to do is remove index 1. So boom, let's take out index 1, which is the number 9, and let's see if it's smaller than index 0. Well, index 0 is the number 3. Certainly it's not smaller, so that should just go back in place. And now 3 and 9 are sorted. We know that these are in the proper ascending order. So now we're going to take our index up to 2, and we're going to check. We're going to pull it out, and we're going to check the previous values and see if any of them are smaller. Or see if any of them, and we're going to see is 4 smaller than any of the previous values. That's how this works. Sorry. Well, obviously 4 is smaller than 9, but it's not smaller than 3. So what's going to happen is we slide down the values that are larger, and then 4 gets put in its place. And now index 0, 1, and 2 are sorted in ascending order. Now we're going to go up to index 3. So 0, 1, 2, 3. We're going to pull out that 8. Now we need to check the previous values, and we're looking for values that are larger. We're going to see is 8 smaller than any of the previous values. Obviously, it's smaller than 9. So 9 slides down, and then 8 gets inserted here. Now index 0, 1, 2, and 3 are properly sorted. So let's keep it going. We're going to move on to index 4. We're going to pull that out. Obviously, 4 is smaller than 9. It is smaller than 8, but it is not smaller than 4. So those, so it's smaller than 9, it's smaller than 8, not smaller than 4. So we're going to slide everything down, and we're going to pop that 4 where it should go. And then finally, we got to take care of our 5. So our index is going to go up to 5, 0, 1, 2, 3, 4, 5. That means we are looking at this one right here. So 5 is smaller than 9. It is also smaller than 8, but it is not smaller than 4. So 8 and 9 slide down. 5 gets inserted. There you go. You now have a completely sorted array. And we did it by inserting the elements where it should go. But again, this one's different because instead of starting at index 0 and then looping forward, we're starting at index 1 and we're kind of looping backwards. So very, very different arrays, or very different sorting algorithms. So here is our Java code for the insertion sort. And once again, we are sorting an array of integers from low to high. And now we get our first for loop. For int j equals 1, as long as j is less than elements.length, j++. And so again, we're starting at index 1. And it says int temp equals elements at j. All right, so again, we're traversing the entire array starting at index 1, and we're going through the entire array this time, not length minus 1. So this is, again, probably the first clue that you're looking at an insertion sort, is that you're starting at index 1 and looping through the entire array. But the next thing we need to do is we need to pull out the current value. So the way we do that is we say int temp equals elements at j, and so we now have this value that's storing our original, the number that we're checking, right? Now what we're going to do is it says int possible index is equal to j. So we're basically recognizing that the element may not need to move. So we're starting here and then we're going to move to the left. So while possible index is greater than 0 and the temp, which again is our original element, is less than elements at possible index minus 1. So instead of looking at the original index, we're now looking at the index below it or previous to it. So while that is true, elements at possible index equals elements at possible index minus 1, and then possible index needs to go backwards. So the while loop loops while the possible index is greater than 0 and the value in temp is less than the value at the possible index minus 1. So again, it's looking backwards and saying, is there anything previous to it that is smaller than what I'm currently looking at? So if the temp is smaller than elements at possible index minus 1, go ahead and do these two lines. And then finally, elements at possible index is equal to temp. What we need to do is we need to set the value of the array at the determined index to the value being inserted. And that was what was originally stored in temp. So what's interesting about the insertion sort is you can still see the swap algorithm in here. Here it says int temp equals elements at j. And then we can substitute possible index for j, because basically right here we're saying int possible index equals j. And then down here, elements at possible index equals elements at possible index minus 1. And then finally, elements at possible index is equal to temp. So we see that same kind of structure that we would normally expect from the swap algorithm. And once again, you're also using a nested loop. We've got a while loop that is nested inside a for loop. Now, again, the good news is we don't have to memorize all of this program code. We don't even necessarily have to understand how every little detail works. We just need to be able to recognize that this is the insertion sort, and we need to have a general understanding of how the insertion sort works. So now that we've gone through it, again, same questions here. Under what condition will an insertion sort execute faster? If the data is already sorted in ascending order, if the data is already sorted in descending order, or it will always take the same amount of time to execute. Consider what we just demonstrated here and the program code. Feel free to pause the video and consider how you would answer this question. I assume you paused the video. We're going to go ahead and get into it. And the answer is if the data is already sorted in ascending order. And the reason for it is if the data is already sorted in ascending order, then you don't have to go through all of those crazy swaps. It basically just checks and says, okay, it's already in sorted order. and then puts it back in place, and then goes to the next one and says, okay, these are already sorted. So again, it would put it back. If they are sorted in descending order, then this thing is going to be swapping constantly, and definitely it's not going to take the same amount of time to execute. So the insertion sort is definitely a little bit different. It behaves differently, and kind of uses some different conditions in terms of how its program code works. Once again, we're looking at some program code here. This method should sort the numbers in the array that's getting passed in here into ascending order, but it does not work. Which of the following lines is wrong? So you've got 5 lines to choose from here. Go ahead and take a minute and read through what's here and see, can you spot the line that has the error? I'll give you a second to pause the video and check that out. And I assume you paused the video, so let's go ahead and see what it is. And hopefully you recognized it's that first for loop. It gets it right that you should start your outer for loop at index 1, because again, we start at index 1 and then we loop backwards. But j is less than elements at length minus, or elements.length minus 1. This is what you would want for the selection sort, but not for the insertion sort. The insertion sort starts at 1 and loops through the rest of the array. So that should just say as long as j is less than elements.length. All right, well, let's look at a couple of things to keep in mind moving forward here. For the selection and insertion sort, you are only responsible for 3 sorting algorithms: the selection, the insertion, and the merge sort. So that is good to know. You must be able to identify the different sorting algorithms by looking at the code, and to sort a list of elements by hand using either sorting algorithm. So just like I demonstrated in here with all of those numbers and sorting things out, you just need to know how it works and being able to trace that through. Therefore, it is imperative that you learn the proper names for these algorithms and practice how they work with each pass of the sort. Loops typically start, when we talk about loops in this class, loops typically start at index 0 and then run through the rest of the array, array length -1 or array size -1. These sorting algorithms that we're looking at, they don't fit these norms. They also may incorporate while loops as well as other inner loops. So these sorting algorithms, you'll notice a change in their loop headers. And then finally, you are required to be able to estimate the algorithm runtime using what are called statement execution counts. So in other words, you need to determine how many passes of one sorting algorithm compared to the others will result in a sorted array. All right, with that, you guys are good to go. You can check out CSAwesome Unit 7, Lesson 6. And of course, we're going to have some additional practice problems available at Classroom. Thanks so much for watching, guys. I'll see you in class.